ugly things will happen. All right. So, y equals a sine of b times x minus c plus d. Whoa. Yeah. So a is the amplitude. A is the amplitude. So for those of you who have taken Algebra 2 recently, and you did the graph things and how graphs change when you do this and that, this is the same type of thing, okay? But only with trig. So A is amplitude. Amplitude is the difference between the max and the min divided by 2. The difference between the max and the min divided by 2. B is the period length. So B is period. Actually, B deals with the period. B isn't actually the period length, but B deals with the period. But we just put period there. C is the horizontal phase shift. And if it's minus C, we go to the right. If it's plus C, we go to the left. And I'll talk about that. What? It's opposite of the sign. Yep. It's opposite of the sign, just like in Algebra 2. Do you remember doing this in Algebra 2? No? Okay. And D is the vertical shift. I don't call it a phase shift because phase shift is left and right. So that's the vertical shift. Now, we do the same for cosine, so I'm not going to write cosine and then all the same stuff down. Okay? Sine and cosine, we do the same type of things. Okay. So, this is where I said to bring your colored pencils. That's all right if you didn't bring them today. It's not the end of the world. So, let's say we have y equals 2 sine of x plus 3. We'll do a very basic one right off the start. Y equals 2 sine of x plus 3. All right. So, what do our numbers stand for? A, B, C, or D? What does 2 stand for? A. That's the amplitude. That's out in front. What is 3? C or D? D, because it's outside the parentheses. So it's D. Okay? So what I do, and what I'm going to have you guys do, is you're going to draw 3 graphs for this one. You're going to draw y equals sine of x. Then you're going to draw y equals 2 sine of x. And then you're going to draw y equals 2 sine of x plus 3. Okay? Problems with that, Shanty, at all? That's good. Now, I have graph paper over here. So a lot of people use my graph paper instead of notebook paper. Some people want to use notebook paper. That's fine. But when it comes to the assignment, if you want to use graph paper, I have plenty of it. Now, yep, you can use marker. Okay, so when I make out my graph, I go, you look at all the squares, I go 1, 2, 3, 4, 5, 6 to get to pi over 2. 6 to get to pi over 2, another 6 to get to pi, another 6 to get to 3 pi over 2, another 6 to get to 2 pi. And then I generally go about 2 spaces for my numbers. In this case, it's probably a bad idea to go 2 spaces for my numbers, but I'll just do it right now and you'll see what it turns out to be. Okay, so I'm going to graph y equals sine of x first. Okay, we're going to look at the major points of sine of x. At 0, where are we at for sine of x? 0. At pi over 2, we're at unit circle. Pi over 2. What's the sine of pi over 2? 1. What's the sine of pi? 0. What's the sine of 3 pi over 2? Negative 1. What's the sine of 2 pi? 0. Now, if you go like this, I'll take points off. It's a smooth curve. Now, understand I have something wrong with my computer and it'll do stuff at certain parts of my screen because parts of my screen is bad, but I want a smooth curve. Okay? Now, that's a green graph. That's y equals sine of x. Then I'll do the red graph. Y equals 2 sine of x. What should 2 sine of x look like? Well, it's 2 times the sine of x. The sine of x is my y value here. So what's 2 times 0? 0. What's 2 times 1? 2. What's 2 times 0? Boy, I don't hear many responses. What's 2 times 0? 0. What's 2 times negative 1? Negative 2. What's 2 times 2? Or 2 times 0? 0. So my red graph is the smooth curve there. Now, what does a plus 3 do to my y values? Moves all of them up by 3. So this is a blue graph, so I move that up by 3. This was at 2, so now it goes to 5, which is right up there because I go every 2 squares. To 3. To 1. And to 3. And that's what it looks like. The blue graph is my final graph. Okay? You can handle that, right? Okay. Let's do a cosine curve once now. Should I still leave it for a few seconds? Okay. Okay, I'm going to move on. Okay, this time I'm going to do y equals negative cosine of x minus pi over 4. Y equals negative cosine of x minus pi over 4. Well, what's the root function of that one? What's the very root function of it? The root, the base, cosine of x. So my first function I'll graph is y equals cosine of x. Then, what minor little thing do I do to cosine of x but before my final answer? What minor little thing do you see there? A negative in front of the cosine of x. So I'll graph the negative cosine of x, and then I'll graph this one. So again, I'll make 3 graphs on this one. So pi over 2. Pi 3 pi over 2. 2 pi. 1, 2, -1, -2. All right, cosine curve. What's the cosine at 0? 1. Thank you for saying that. We are at 1. What's the cosine at pi over 2? 0. What's cosine at pi? -1. What's cosine at 3 pi over 2? 0. What's cosine at 2 pi? 1. Okay, if you're going, well, that doesn't look anything like the sine curve. Well, it does. It's just shifted over the sine curve. If you just think about it, it's just the shifted over sine curve. Because if we would keep going, 1, 2, 3, 4, 5, 6, our next point would be right there, wouldn't it? Okay, so it's just the sine curve. All right. So negative cosine of x does what to each number? It reflects around the x-axis. Very good, people. So positive 1 becomes a -1. 0 stays at 0. -1 becomes a positive 1. 0 stays at 0, like that. We good with that? Okay, minus pi over 4. Moves it left or right? Moves it right, pi over 4. Now, how many squares on my graph is pi over 4? Why is it 3? Because pi over 4 is 1/4 of pi, right? And if I went 12 squares to get to pi, 1/4 of 12 is 3. So I'm moving 3 squares, 1, 2, 3, to the right. So from the green, every point moves 3 squares to the right. Because pi is 12 squares over. Because if I go to 6 to get to pi over 2, it's 12. And the reason why I do that, in the past, I always used to go 4 squares. But then if you have a pi over 6 or a pi over 3 involved, then you're somewhere in between a square and it's hokey. Does it really matter how far you go when you first set up the graph? No, as long as you put the dots in the right spaces proportionally to where you're at. So, I hope you understand that. Okay, we're going to do one more, and then I'm going to let you roll with this. Okay, so y equals -2 sine of let's go x plus pi over 3 plus 1. Okay, we're doing 3 things here, so it'll be how many graphs? 4. 4 graphs. You guys are smart. This will not be any challenge for you guys. So what's the base function? Y equals sine of x. The first thing that we're going to do to it is multiply it by a -2 for the amplitude. Then what are we going to do to it? We're going to slide it. Which way are we going to slide it? Left by pi over 3. And then we're going to graph the final function. All right. Normal sine curve. Where do we start at? 0, 0. 0, 0. Pi over 2, 1. Pi. 3 pi over 2, -1. 2 pi. Okay. -2 sine of x. What does that do to the graph? It flips it over the x-axis and makes it twice as high and low. Yeah, whatever. So 0 is still at 0 because -2 times 0 is 0. 1 times -2 is -2. 0 times 0 is 0. -1 times -2 is a +2. 0 times 0 is 0. Here's your little DNA curve. That's not very pretty DNA because we went twice as high and twice as low. No, that wouldn't be DNA either. All right. So, and then in orange, we'll go fatter orange, plus pi over 3. How many squares is pi over 3? Why is it 4? Shanty, you're correct. Why is it 4? Because it's pi over 3, so it's 1/3 of 12, which is 4 squares. Okay? So everything goes 4 squares back. Everything goes 4 squares back. Because if we have 12 squares to get to pi, we take 1/4 of 12. And what's the last thing that we do to the whole graph? Up 1. Plus 1 at the end. Is it vertical? So we go up by 1. 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 Ta-da! That's kind of what I'm looking for today. Okay? There is graph paper in there. All right. So here we go. The assignment today that I'm going to give. Because we're going to have a today assignment and a tomorrow assignment, and they're going to look very similar. The today assignment, and all you have to do is graph. You don't have to say what the amplitude, phase shift, and range is. Just graph. Okay? So today, I want you to do 63, 65, 73, and 77. Just 4 of them. Tomorrow, we'll look at those on page 117. Tomorrow, we're going to look at those And then we're going to do 67, 79, 80, and 81. So the play people, you guys kind of, if you figure out what we're doing today, then it's just 4 more of the same types of problems for tomorrow. Okay? There we go. I recorded this, so it should not. So if you get stuck, hopefully you can look at the